We're going to continue with our sub-factory build program with the 625 series. The 625 series is built similar to the 800 series, so we have selected a 625S. We're going to be building a two-stage pump today with this product. We're going to be building the 8-inch version of this model. So we've selected a standard package. We've also selected, as was with the other product, a single stage or per stage package, but this one is going to be a complete or a full impeller. So that would be denoted by the part number again being SSO to be a full impeller. With the per stage package, again we'll review what's inside of it. It has the chamber, the impeller, the split cone and the split cone nut, the seal ring and the bearing included with the chamber. Along with the single stage or the standard package, we have our discharge piece, we have an upper chamber, we have the inlet screen locking mechanism, and up in the very top we have the bolt package that's included. With the variable component package, again we have selected a variable component package because we're building an 8-inch motor. We've selected for an 8-inch motor which has the shaft with an 8-inch coupling, the cable guard, and the straps. Along with that, again, we have the bolts that go to the straps, the lock washer or the washers for the straps, the label, and the two rivets that hold those in place. And again, with the other packages, both the variable component package and the standard package, there is a bill of materials that's included, so you know exactly what's included in each of the package sets. Now we're going to go ahead and take the packages apart and review individually what's in the package. Now that we've unpackaged the per stage or single stage package that we've selected, let's go ahead and again review what's included inside of the kit. We have the complete chamber. It has the seal ring and the bearing already installed for you, and it's a standard chamber that goes all the way through. There's no support disc on the inside like there will be in the upper chamber. We have a full impeller which has the guide vane coming all the way out to the very tips or edges of the impeller itself. And we have the split cone nut and the split cone that's installed inside of the impeller. Now moving over to our standard package, again our 8-inch standard package includes the locking portion to the screen. We have the screen, and then if you are using a standard motor with only 3 leads, we have one recess here. There's also in the inlet a second recess, but because it's being used for a standard motor and not a star delta with 6 leads in the motor, we are blocking this area by this plate which is screwed in place onto the inlet. The inlet also has a seal ring installed in it, and then we have a standard impeller, full size again, where the guide vane of the impeller comes all the way out to the plate portions. Again, a split cone nut and a split cone inside of the impeller. The kit also includes the mounting hardware to mount the pump end to the motor, and there is a protective device that slides over the leads to protect the motor leads. Next, we have the discharge chamber. If you remember, in the 475 series, we took the discharge piece apart. This has the exact same assembly process as does that product. So please review that if this happens to come apart. Next, we have the upper chamber, which does not have the check valve seat because that's included in this portion of the discharge head. And we'll notice that the upper area for this model is sealed, and on the inside, turning it over, we'll notice that into the chamber itself is the up thrust washer. Because of the similarities between the 625 and 800S product to the 1100S pump, the only thing that changes on this product is the dimensional changes in the inlet, and the chambers grow in height and size. This unit that we've selected here is a 6-inch unit, and that is dependent on where the holes are located. In this case, they're located toward the inner surface. On the 8 and 10 inch units, the holes will be located further out on the flange. The type of spacer that is used in the assembly, there are motor sizes that actually grow in the type of product and the fit of the shaft. So this is a standard 6-inch NEMA, would be used for standard 6-inch NEMA fit motors. This would be the spacer that would be used for the 8-inch standard NEMA fit motor. And sometimes, because again the varying types of motor sizes, there may actually be this type of a spacer used for a smooth inner surface on the coupling. Please refer to the service manual for the type and size of spacers that you should be using for the proper motor or proper pump build. Now, as we bring the product over to assemble, we are going to select the correct building spacer. In this situation, because of the high torque that has to go to the shaft on the split cone nut, we're selecting a spacer that actually has splines on it, and it will interlock into a building plate to prevent the shaft from spinning during our assembly. And also because of the weight of the inlet, we're going to go ahead and set the inlet first onto the build plate instead of having to lift it over a tall shaft. Make sure again that the build plate is made or positioned such in your vise that you have the build plate actually above the top of the vise surface so as not to prevent the inlet from seating all the way down. So now we're ready to fit the shaft to the spacer. Before you actually fit the shaft to the spacer, because of the tight fit to the spline, it may be necessary to remove the O-ring out of the coupling so that it will slide freely in and out. The other thing that you can do is you can spray soapy water on that. I've selected for this to go ahead and remove it, but you have to make sure that you put it back in place after your assembly is completed. And take your Allen wrench and tighten down the bolt. So after you finish tightening the bolt, you want to make sure that the shaft doesn't rot on the assembly. Now we're ready to add our first impeller to this. Again, you may have to back the nut off a little bit, slide it down the shaft, and sometimes if it gets stuck like it is here, you can back it all the way off, take a screwdriver and right in the gap, open the gap slightly, and then slide the split cone down the shaft almost to where it's going to be positioned. Then you can add the impeller and the split cone nut. Again, wanting to make sure we have soapy water up where it seats, and then firmly seat it all the way down. Again, at this point, we want to take our 2 screwdrivers and make sure that the cone is pulled all the way up in through the impeller. Now we take our spanner, sliding the tool down over the shaft, and then taking it to the proper torque. So make sure that you're well positioned in your vise. Now we can add the chamber. Again, we're checking the seating surfaces, making sure that there's nothing on them that would prevent them from seating properly. Make sure that the mating surface here is also clean. Make sure it's seated all the way down. Now we can add our next impeller. Again, remember that you might have to back off the nut to have it slide smoothly down the shaft. Put some soapy water on it. Seat it down. Make sure that it's seated, the cone is seated all the way in the impeller. Now we're ready to add our upper chamber. Again, the upper chamber has the upthrust washer on the inside and it's solid on the top. Make sure it's firmly seated. In this situation, we've selected a standard 6-inch NEMA-fit spacer to be used in building this pump. Again, because of the size and the weight of the inlet, it's always better to install the inlet directly after placing the spacer. Make sure that it firmly seats all the way down and that the vise or the tool is far enough up in the vise not to interfere with the fit of the vise down onto the build plate. Now, just like we did in the last series, from the 625 to the 800S that's built on the spline spacer, we want to remove the O-ring out of the coupling so that it will freely slide down on the spline spacer. Put this in place, and again, using the bolt, secure the bolt up and through the build plate. Again, ensure that the shaft does not move while it's in place. Now at this point, we can go ahead and we can add our impeller. As it's a larger size shaft, just like with the last series, if we have the large impeller, it may not move as freely down the shaft, so you may have to back the nut off or put it down as an individual item. Remember to pull up on the impeller and down on the nut while we're bringing it down. Now at this point, go ahead and squirt soapy water onto the shaft, and now bring the impeller all the way down and fully seat it into the inlet. Just like we've done on all the other series of units to this point, go ahead and take 2 screwdrivers and ensure that the cone is pulled all the way up into the impeller. Now we're ready to take our special spanner, which is designed for the 1100S and the 1000S product, and we'll slide this onto the shaft and onto the nut. Taking our torque wrench and setting it to the proper torque, and the proper torque for this would be 300 Newton meters to 250 Newton meters as the minimum. Again, it's important when you're setting the torque not to have the pump shift, and also to make sure that you're putting nice even pull and not doing a jerky motion while doing this. And this may be difficult to achieve with this large amount of torque that's required. Bracing yourself on the table may be a necessity. Now, after finishing the torque on the split cone nut, now we can add the upper chamber, just like the 625 and 800S has the thrust washer all the way down inside in the chamber itself. This again placed onto the inlet. Make sure that the inlet area is clean and free of burrs, and the same holds true for the seating surface of the chamber. Once in place, we can add our discharge piece. Again, remember that this is multiple components, so you'll want to hold on to the ring so that it doesn't come off. And again, you'll line up the slots just like we did with the previous model with the holes that are provided. Then we can take our straps, slide the bolt in first, and then bend slightly outward to allow the strap to go up into the relief, and then slide upward. Make sure that this lip area goes all the way in on the housing. Now we're ready to add the washer and the nut. Again, there is a recess to the washer itself. So we're going to make sure that that's facing upward. And again, when we're tightening these down, you want to make sure that the straps are straight up and down on the assembly, and that you tighten diagonally from side to side, just like you would if you were tightening down a tire when changing a tire on the car. Once we've got the straps snug, then we're ready to begin the process of tightening down the straps with a three-step process again. And our first step is going to be it's going to be 80 Newton meters, which is 59 foot-pounds. Make sure that whenever you're tightening these, again, that the head of the torque wrench is not bottoming out against this and giving a false sense of torque. Now we're ready to move to our next point, which is 100 Newton meters, which is 74 foot-pounds. After we've removed the torque wrench from the straps, it's not unusual for the straps to actually gap out like this, having twisted. It's also not unusual for the washer to be extended out beyond the surface area. So we're going to take a hammer and we're going to actually just bend these back and make sure that the washer is located flush and even with the surface. Take your Allen bolt and unloosen the wheel bolt that's holding the unit in place. Make sure that if it's a taller unit, that it's well supported so that it doesn't tip over. Also, for the heavier units, you want to make sure that you have a lifting device to be able to remove this from the vise. Again, this is a short, lighter version, so we'll go ahead and lift this directly out of the build stand. So once we've removed it from the build stand, and because it's been pulled all the way down, this is the best opportunity to take your downward measurement in the unit. So we're going to take our depth veneer, and again we're going to be going across from a solid surface to a solid surface, and we're going to be measuring down inside the coupling all the way against the shaft area. Again, your depth veneer, you want to make sure that it's well located and that you don't end up going into the build hole in the coupling itself. Once it's firmly in place, then go ahead and tighten up the screw and remove it and check the end play. So the minimum down is 100 plus minus 0.5, so we can go down to 99.5 or up to 100.5. In this case, we are 99.9 millimeters. So the down in play is good. Then just simply push the shaft upward, and then again take the up travel in the unit. Again, resecure the screw and remove your depth veneer. And here the minimum up is 103. Now we can check our rotation. On the smaller units, you can do this by hand. On the larger units, it may require a specialty tool made out of an old shaft with a handle on it. You want to make sure that there are no metal-to-metal noises while you're rotating it, so we have good rotation at this point. Again, on this product, if you've removed the plate, if it was going to be built for a motor that was star delta or 6 leads, you'd be using both sides of the recessed areas that are provided. If you're only having a motor that is a standard motor with 3 leads, you'll want to make sure that you put this plate back in place and secure it and secure the screws. And before we mount or take the pump over to mount it to the motor, it's very important that you remember to take the O-ring that was removed from the coupling and put it back into the coupling area or the recess of the coupling, and that it's seated properly.